Our perceptions are there. They're there to guide adaptive behavior. They're not there to show you the truth.
So none of this is real in the way we think is real.
Whatever reality is, you don't see it. Dark matter and dark energy are most of the energy and matter that's out there. Our interface just plain flat out hides them. A century from now, they'll look at us like we look at the physicists of 1890 and go, how could they have been so dumb?
In your book, The Case Against Reality, you make the bold claim that the world we see with our eyes is not real. Can you explain this idea?
Right. So most of us intuitively think that surely the way that evolution will make our senses more fit is to make them tell us more truths, or at least the truths we need to know about objective reality. That's the standard view, and it was the view I took. I mean, that's sort of what we're taught or just even assumed. The technical question that I and my team asked was, what is the probability that natural selection would shape sensory systems to see true properties of objective reality? And to our surprise, we found that the answer is precisely zero. What we're seeing is what we need to see to stay alive long enough to reproduce. So in other words, we're seeing what we need to guide adaptive behavior. Full stop.
So none of this is real in the way we think is real.
So their perceptions are real as perceptions, right? We are having our perceptions, but we've assumed that there's a pretty tight relationship between our perceptions and reality. Our perceptions are there. They're there to guide adaptive behavior. Full stop. They're not there to show you the truth. In fact, the way I think about it is they're there to hide the truth because the truth is too complicated. It's just like if you're trying to, use your laptop to write an email, right? What you're doing is toggling voltages in the computer. But good luck trying to do it that way. The reason why we have a user interface is because we don't want to know that quote-unquote truth, the diodes and resistors and all that terrible hardware. So what evolution gave us was perceptions that guide adaptive behavior, and part of that process, it turns out, means hiding the truth and giving you eye candy. Whatever reality is, you don't see it. You see a user interface. The distinction that we make between living and non-living is not a fundamental distinction. It's an artifact of the limits of our interface. Right? So this is a new wrinkle, and this is an important wrinkle. Now, it's much more complicated. Certain things are obviously living. I'm talking with you. I'm obviously interacting with something that's alive and conscious. But when we get down to an ant, it's obviously living. When we get down to a virus, now people wonder. And when we get down to protons, people say it's not living. And my attitude is, look, I have a user interface. The interface is there to hide certain aspects of reality, and others it's an uneven representation. Put it that way. Certain things just get completely hidden. Dark matter and dark energy are most of the energy and matter that's out there. Our interface just plain flat out hides them. Mm-hmm. So what's interesting about this is that our scientific theories are precise enough and rigorous enough to tell us certain limits. The physicists are saying precisely the same thing, that space-time is doomed. We've assumed that space-time is fundamental. We've assumed that for several centuries, and it's been very useful. But now physicists are saying space-time is doomed. There's no such thing as space-time fundamentally in the laws of physics. So the physicists know that their best theories, Einstein's gravity and quantum field theory put together, entail that space-time cannot be fundamental, and therefore particles in space-time cannot be fundamental.
Yeah, the physicists are space-time skeptics.
Yeah, they're saying that, so what they're looking for is some new mathematical structures beyond space-time, beyond Einstein's four-dimensional space-time. And by the way, they're succeeding now. They found something called the amplitude-hedron. So they're finding that if they let go of space-time completely, they're finding new ways of computing these scattering amplitudes that turn literally billions of terms into one term. So what we're finding is there's this whole new world now beyond space-time that is making explicit symmetries that are true of the data that cannot be seen in space-time. But they don't know what this world is about because Einstein's theory and quantum theory can't tell us what's beyond them. All they can do is tell us that when you put us together, space-time is doomed at 10 to the minus 33 centimeters, 10 to the minus 43 seconds. Beyond that, space-time doesn't even make sense. I think that science now has enough experience to realize that we should not believe our theories in the sense that we've now arrived. In 1890, it was a lot of physicists thought we'd arrived. They were discouraging bright young students from going into physics because it was all done. And that's precisely the wrong attitude.
Yep.
Forever. It's the wrong attitude forever. The attitude we should have is a century from now, they'll be looking at us and laughing at what we didn't know. And we just have to assume that that's going to be the case. Just know that everything that we think is so brilliant right now, our final theory, a century from now, they'll look at us like we look at the physicists of 1890 and go, how could they have been so dumb?
Yeah.
I think the right way we're going to have to do that is to come up with a deeper theory than space-time, in which there may not be the notion of time.